Good evening, Swati. Yeah, I don't know why Bhavishya has not joined the meeting today. Okay, so you're taking a test now, Swati. Start answering these questions. Write down the question. Yeah, write down the question and then answer it. I have the answers ready. You can see the answers as soon as you finish the test. All right?
Yes, ma'am.
Yeah. Once you finish these 5 questions, tell me. I'll take you to the next slide. There are a total of 10 questions. Once you finish these, once you finish answering these 5 questions, tell me. I'll take you to the next slide. All right?
Yes, ma'am. Along with the question.
Yeah, please write the question also. Yes. Yeah. Start working, okay?
Yes, ma'am.
Yeah, I'm putting myself on mute, but I'm here only. I'm sitting here only. So you can call out to me anytime you want to say something. All right?
Yes, ma'am.
Yeah. Good evening, Bhavishya.
Good evening, ma'am.
Good evening. You just joined?
Yes, ma'am.
All right. So we are taking a test now, Bhavishya, from this chapter, Understanding Quadrilaterals.
Okay, ma'am.
Yeah. Answer one by one. Please write down the question along with the 4 options and select the correct option. Sometimes you have to work to get the correct option. Yeah, once you finish answering these 5 questions, let me know. I'll take you to the next slide. There are a total of 10 questions. Both of you have learned this chapter in school, so you can try and then we'll discuss and see the answers. So Bhavishya, I'm right here. If you want to ask something, you can just talk to me. I'm right here, but I'm putting myself on mute, okay?
Okay, ma'am.
Yeah. Completed? Swati and Bhavishya?
Last question, ma'am.
Okay. What about you, Bhavishya?
Ma'am, I'm doing fourth question.
Fourth one. Okay. Okay, written the fifth question. Girls? Why no response? Swati and Bhavishya?
Yes, ma'am.
Okay. Yeah.
Written the question, ma'am, and solving. Written.
Okay, okay. Okay. So you can see questions 6 to 10 now. Completed, children? Swati and Bhavishya?
No, ma'am. Only one more question is left.
Okay, fine, fine. No hurry. I'm just asking you. What about Bhavishya?
I'm doing, ma'am.
No, which one, darling? I know you're doing, but which one are you working?
7th one, ma'am.
All right, fine, fine.
Done, ma'am.
All right, Swati. What about Bhavishya? Have you finished, Bhavishya?
Ma'am, I'm doing that 10th sum, ma'am.
10th one, huh? Okay, fine. Swati, we'll just wait for her. 2 minutes, okay?
Yes, ma'am, sure.
Yeah.
Done, ma'am.
All right, children. Just a minute. Just give me a minute. I'll get back. Yeah, what's the answer for the first one? The two diagonals are not necessarily equal in an
Rhombus, ma'am. Rhombus, ma'am.
yeah, because in a rectangle, diagonals are equal. In a square, diagonals are equal. In an isosceles trapezium, diagonals are equal. So in a rhombus, the diagonals need not be equal. Because why is it given like this? Need not be equal because a square is also a rhombus. A square is also a rhombus. See here. A square is a rhombus. Is a rhombus. But a rhombus need not. But a rhombus need not be a square. Need not be a square. A square is a rhombus because what is a rhombus? A quadrilateral in which all the sides are equal. And in a square, all sides are equal. So it's a rhombus. A square satisfies the definition of a rhombus. A square satisfies the definition of a rhombus. What is a rhombus or when is a quadrilateral called a rhombus? A quadrilateral is a rhombus if all the sides are equal. If all the sides are equal. So a square, see a rectangle is not a rhombus because in a rectangle only opposite sides are equal. In a rectangle only opposite sides are equal. A rhombus is a quadrilateral in which all the sides are equal. And in a square, all the sides are equal. So a square is a rhombus. A square is a rhombus. And in a square, the diagonals are equal. In a square, the diagonals are equal. So the statement is the two diagonals are not necessarily equal in a rhombus. Then they need not be equal in a rhombus. Very good. What's the next one? Yeah, so this is the answer. The diagonals of a rhombus are not necessarily equal, but the diagonals in a rectangle, square, and isosceles trapezium are always equal, which you know. Yeah. What's the length of the side of the rhombus?
10 centimeter, ma'am.
Yeah, 10. Okay. Kanishka, I'm sorry,
10 centimeter.
Bhavishya?
Ma'am, 10 centimeter.
Okay, fine. So the diagonals are 16 and 12. So it will be 16. So 8 and 8, 8 and 8, 12. So 6 and 6. Now we know that the diagonals of a rhombus are perpendicular to each other. They are perpendicular to each other. So this one is a right triangle. There are 4 right triangles. You can take any one. All these 4 are right triangles. All these 4 triangles are right triangles. Now when you take up this right triangle, 8, 6. So we need to find the hypotenuse AD. So by Pythagoras theorem, in right triangle AOD by Pythagoras theorem, write the result and then substitute the values, and AD is equal to 10 centimeters. So the length of each side is 10 centimeters. Just in case you want to take a screenshot, keep taking, children. Supposing you want to. Any doubt here?
The steps of dividing the length of the diagonals by 2 is not given, ma'am.
Okay, you're saying that I have not given the reason for writing 8, 8, is it?
Yes, ma'am.
Very good. Okay, fine. I'll write it now. Yeah. So in a rhombus, diagonals bisect each other at right angles. At right angles. AC is equal to 16 centimeters. This implies OA is equal to OC is equal to 8 centimeter. BD is equal to 12 centimeter. This implies OB is equal to OD is equal to 6 centimeter. Also, angle AOD is equal to 90 degrees because they bisected right angles. Yeah. Is it fine now? Swati? Yeah.
Yes, ma'am.
Yeah, very good. Yeah. So I said, if you want to take a picture, please take. Yeah. What are the angles? Two adjacent angles of a parallelogram are given. The value of x is
32 degrees, ma'am. 32, ma'am.
32. What is the property? The adjacent angles are?
Add up to 180 degrees, ma'am.
They are supplementary. Very good.
They are
Adjacent angles of
co-interior.
very good. Adjacent angles of a parallelogram are co-interior angles. So they are supplementary. The value of x is 32. Any questions here, children? You got the right
No
answer
doubts.
still? Okay. Bhavishya?
No doubts, ma'am.
Okay. The diagonals do not necessarily intersect at right angles in a
Parallelogram, ma'am.
parallelogram. Parallelogram. Correct. What's the perimeter of the rectangle?
70 centimeter, ma'am.
70. What about
Yes,
you,
ma'am.
Swati? Okay. So the length and breadth are in the ratio of 4:3. So let the length be 4x. So let the length be 4x and the breadth be 3x. Now we have to find BD using Pythagoras theorem. We'll have to find BD using Pythagoras theorem. Why should we find BD? Because it's given that the diagonal measures 25 centimeters. The diagonal measures 25 centimeters. So we need to make use of that information. The ratio of the length and breadth is given. So 4x, 3x. And then the length of the diagonal is given. So how do you connect? See, we need to connect the information given. How do we work? How do we know that we have to use Pythagoras theorem? You have to just connect the information given. So how do you connect? See, the ratio of the length and breadth is 4:3. So 4x, 3x. Okay. Then the length of the diagonal is 25. With this, we have to find the perimeter of the rectangle. To find the perimeter, you need the length and breadth. So we need to somehow find the length and breadth using this information, 3x, 4x, and 25. So how do we connect? How do we connect these three things? 3x, 4x, and 25. How do we connect them? Through Pythagoras theorem, using Pythagoras theorem. So this is what is the theorem for a triangle ABD? AB square plus AD square is equal to BD square. It's not 4x squared. It's not this. It is 4x the whole square, 3x the whole square. Okay, so you get 16x squared 9x squared is equal to 625. So 25x squared is 625. X squared is equal to 25. X is 5. So we found the value of x. So 4 into 5, 20 is the length. 3 into 5, 15 is the breadth. Now the perimeter is 2 into L plus B. Do you have the same working, children?
Yes, ma'am. Yes, ma'am.
Okay. The bisectors of any two adjacent angles of a parallelogram intersect at
90 degrees, ma'am.
Bhavishya said that or Swati? Bhavishya. Very good. Okay, what is Swati's answer?
Ma'am, it's D, 90 degrees.
90 degrees. Okay. Yeah, Bhavishya, explain why. Do you remember that as a property, or you know the explanation?
Ma'am, as property, ma'am.
As a property, you know. You don't know the reason behind that, right?
Yes, ma'am.
Okay, what about Swati?
I'm same, ma'am, as a property.
Oh, you just know that as a property, you don't know the reason. All right, it's very simple, children. It's very, very simple. Now listen to me very carefully. See here. Name this figure. What do you call this figure?
Parallelogram, ma'am.
Parallelogram. What are these two angles called?
Adjacent angles.
Adjacent angles. Now, this is the bisect. Now, let me call it ABCD. Now, this is the bisector of angle A, okay? So, if this whole angle is 70 degrees, it will be 35 here and 35 here, correct?
Yes, ma'am.
Yeah. This is the bisector of angle B. Okay, let's say that the bisectors, they meet at O. This is the bisector of angle B. So, if this is 110 degrees, it will be 55 here and 55 here, correct? See, the adjacent angles are supplementary, yes or no?
Yes, ma'am.
Yeah, now I'm just taking, they're supplementary. So if I take this angle as 70, this one has to be 110 only. Correct? No,
Yes,
let me
ma'am.
come again. 1 minute. Let me come again from the beginning. 1 minute. See here. Parallelogram ABCD. I'm saying this angle, if this is 70, what is the measure of this angle?
110, ma'am.
Because adjacent angles are supplementary. Now this is the bisector. So how much is it here? 35? 35, correct?
Yes, ma'am. Yes, ma'am.
Bisector. So it will be 55, 55, correct?
Yes, ma'am. Yes, ma'am.
Now is AOB a triangle? Is AOB a triangle?
Yes, ma'am.
What's the measure of this angle?
35 degrees, ma'am.
What's the measure of this angle?
55 degrees, ma'am.
Then what is the measure of this angle using angle sum property?
90 degree, ma'am. 90 degree.
90 degree. Now let's take a different example. Let's take, is it always, why should it be 70 and 110? So maybe we'll take 50 here. Shall we take 50 here?
Yes, ma'am. Yes,
Okay, 50 degrees. Then what will this angle be?
130 degree, ma'am.
130 degrees. Bisector, bisector. They meet at O. What's the measure of this part of A?
25 degrees, ma'am.
What's the measure of this part of B?
65 degrees, ma'am.
65 degrees. Is AOB a triangle?
Yes, ma'am.
What's the measure of A?
25 degree. 25 degree, ma'am.
This one?
65 degrees, ma'am.
Then what's the measure of this angle?
90 degree. 90 degrees, ma'am.
90 degrees, ma'am. 90 degrees. So you take any example, you'll always see that this angle is 90 degrees. So these are the bisectors. Okay, these are the bisectors. This is the bisector of angle A, this is the bisector of angle B. They are the bisectors of the adjacent angles. They always intersect. See, they'll always meet. This is the bisector of A. This is the bisector of B. So they are the bisectors of the adjacent angles A and B. The bisectors of the adjacent angles always meet at right angles. They'll always meet at right angles. Okay, so now we have seen this numerically. Now let's see how to write the proof for that. Okay, let's see how to write the proof for that. I have it worked, so let me show that. Okay, now see the figure here. So here I've taken up a parallelogram ABCD, and AP is the bisector of angle A, BP is the bisector of angle B. Okay. What is angle 1? Half of angle A, correct?
Yes, ma'am.
What is angle 2? Half of angle B, correct?
Half of angle B. Yes, ma'am.
Okay. Now what is angle 1 plus 2? Half of angle A plus half of angle B, correct?
Yes, ma'am.
Now
Yes,
take out
ma'am.
half common. Yeah, take out half common. Okay, so you will get half of A plus B. Yes or no?
Yes, ma'am. Yes, ma'am.
Yeah, now A plus B means this is A. This one is A, this one is B. How much is A plus B?
90 degrees, ma'am.
No. Adjacent angles are supplementary.
180 degrees, ma'am. Yes, ma'am.
Adjacent angles, A and B are adjacent angles, they're supplementary. This angle A and this angle B, they're adjacent angles, they're supplementary, 180. So you'll get 1 plus 2 is 90. 1 plus 2 is 90. Now take up this triangle APB. Now take up this triangle APB. In right triangle, oh, not right triangle, sorry. In triangle APB, or PAB, angle 1 plus angle 2 plus angle P, this is angle P, is equal to 180. 1 plus 2 is how much? What is 1 plus 2? 90. So 1 plus 2 is 90. Plus P is equal to 180. So angle P is equal to 90 degrees. Understood, children?
Yes, ma'am. Understood. Yes, ma'am. Understood.
Yeah, please make a note of this. Write down in your notebook. Done, children?
Done, ma'am.
Yeah. See, when we say angle A, it is not this angle A. See, angle 1, this angle 1 is half of this angle A. This angle 1, because this is bisecting. AP bisects angle A. So this half, this one is angle 1 is half of angle A. Angle 2 is half of angle B. Angle A is this full angle. Angle B is this full angle. Half of A, half of B. Now when you add these two, you'll get half of A plus half of B. Half common, A plus B. A plus B is 180 because they're adjacent angle, they're supplementary. So you get angle 1 plus 2 is 90. Now after this, we need to take up this triangle. Angle 1 plus angle 2 plus this angle is equal to 180. But 1 plus 2 is 90. Plus P is 180. So P is 90 degrees. All right, children. If an angle of a parallelogram is 2/3 of its adjacent angle, the smallest angle of the parallelogram is
72 degrees, ma'am. 108 degrees, ma'am. Ma'am, I got 72 degrees.
the smallest angle. The smallest angle is 72 or 108.
I'm 72 degree.
Okay, let's see. So one angle is 2/3 of its adjacent angle. Supposing this angle is x, then this adjacent angle will be
2 by 3x, ma'am.
2 by 3x or 2x by 3. 2 by 3x or 2x by 3. One angle is 2/3 of its adjacent angle. So in a parallelogram, if this angle is x, its adjacent angle will be 2/3 of x. But what is the relation between the adjacent angles? They are supplementary. So x plus 2 by 3x is equal to 180. So on working this, so if you take parallelogram ABCD, you know that the adjacent angles are supplementary. In parallelogram ABCD, A plus B is equal to 180. Adjacent angles are supplementary. If you take angle A as x, then angle B will be 2 by 3x is equal to 180. So on taking the LCM, 5 by 3x is 180. X is equal to 180 into 3 by 5. X is 108 degrees. X is 108. We need to find the smallest angle. The angles are x and 2 by 3x. The smallest angle, 2 by 3 into 108. $72 degrees. X is 108, but the smallest angle is 2/3 of x, which is 72 degrees. They're talking about adjacent angles. So I've taken parallelogram ABCD and A and B are the adjacent angles. A plus B is 180. One angle is x, the other angle is 2/3 of x. So x plus 2 by 3, x is 180. On working that, you get x is 108. But what is the smallest angle? 2/3 of x. So 2/3 of 108, which is 72 degrees. All right, children?
Yes, ma'am.
Okay. The diagonals do not necessarily bisect the interior angles at the vertices in a
Rectangle. Rectangle, ma'am.
correct. Rectangle is the correct answer. The diagonals need not necessarily bisect the interior angles at the vertices in a rectangle. What about a parallelogram? Now, supposing, do we understand what this means, children? Or
Yes,
again, you
ma'am.
just know it as a property?
Ma'am, ma'am, in a rectangle, the diagonals won't be perpendicular to each other, ma'am. If they are not perpendicular, then the angle that is formed in the vertices will not be equal, ma'am. In case of a square, that the diagonals is perpendicular, ma'am. So in each of the angle, if it bisects, then one of the angle will be 45 degrees, ma'am. It's not same in rectangle and parallelogram, ma'am.
Correct. Correct. In a rhombus and in a square, that is a figure where all the sides are equal. In a rhombus and in a square, the diagonals bisect the interior angles at the vertices. So if you take a rhombus, the diagonal, if you join the diagonal AC, the diagonal AC bisects angle A, it bisects angle C. The diagonal AC, it will bisect this angle A and angle C. Similarly, the diagonal BD will bisect angle B and angle D. In a rhombus and in a square, where all the sides are equal. The diagonals do not necessarily bisect the interior angles of the vertices in a rectangle. It does not bisect in a rectangle. That is in a square also, in a square, all the sides are equal, no? So the diagonals, this diagonal bisects this angle and this angle. This diagonal bisects this angle and this angle. In a rhombus and in a square, the diagonals bisect the interior angles at the vertices. What's the value of x?
8, ma'am. 8 centimeter, ma'am.
8. So how do we work it? All the sides are
Shall
equal.
I say?
Correct. Have you done the same thing, all of you? Both of you?
Yes, ma'am. Yes, ma'am.
Okay. Okay.
Ma'am, can you show me the 8th question answer?
8th, yeah.
Thank you, ma'am.
Yeah.
Took screenshot, ma'am.
All right. Yeah. If one angle of a parallelogram is 24 degrees, less than twice the smallest angle, then the largest angle of the parallelogram is
112 degrees, ma'am.
sorry?
112. Ma'am, 112 degrees.
Okay, both of you getting the same answer. Very good. So if one angle of the parallelogram is okay, both of you take a picture of this answer and share it on WhatsApp with me. Only the 10th one.
Yes, ma'am.
Quickly. Yeah, I've received from Swati.
Ma'am, I haven't worked for this one, ma'am.
How did you get the answer then? 112?
Ma'am, by calculation, I have got it.
Yeah, whatever you work, just take a screenshot and send it to me. Yes, Swati, you're right. Very good. Okay, so if one angle of a parallelogram, very good, yeah. If one angle of a parallelogram is 24 degrees less than twice the smallest angle, then the largest angle of the parallelogram is. So it's given that one angle is 24 less than twice the smallest angle. See, in a parallelogram, we have only two angles because like if whatever is this angle, opposite angles are equal. So this also will be the same thing. And then whatever is this angle, the same will be this angle. So we have only two angles in a parallelogram. We have only two angles in a parallelogram. So whatever is this one angle, this also is the same thing. Whatever is this one angle, the same thing here. So basically, we have two different angles in a parallelogram. So of those two angles, one will be small, one will be large. Yeah.
Ma'am, I have sent, ma'am. I forgot to switch on the network, so I have sent it late, ma'am.
Okay, okay, Bhavashya, I just saw that. Okay. So basically, there are only two angles in a part. There are four angles, but the measures are only two different angles. Whatever is, because in a parallelogram, opposite angles are equal. So whatever angle is here, the same is here. Whatever is this one, the same is this one. So see, basically, there are only two angles. So one angle of a parallelogram is 24 less than twice the smallest angle. So they are talking about the two adjacent angles because opposite angles will be equal. Opposite angles are equal. They are talking about adjacent angles. So if one angle is x, the other angle is 2x minus 24 because it's 24 less than twice the smallest angle. So you should say let the smallest angle be x. Let the smallest angle be x. So what is the other angle, the largest angle? It's 24 less than twice the smallest angle. It's 24 less than twice the smallest angle. But we know that these angles are supplementary. So add up and equal to 180. On solving this, x is 68. The question is to find the largest angle of the parallelogram. So this is the smallest angle x. Find the largest angle. 2x minus 24. So 2 into 68 minus 24, which is 112. All right, children?
Yes, ma'am.
All right.
Ma'am, ma'am,
Yeah?
ma'am, I have done the second sum in different method, ma'am. Can we do like that, ma'am?
Yeah, one second. Yeah, I'm seeing that. Swati, you received all your books, no?
Yes, ma'am, I received, ma'am.
Yeah, okay.
I'm sorry, ma'am. I didn't pick up the phone, ma'am. Because I
Yeah,
was
yeah, yeah.
tired and I slept after the school.
Yeah, yeah, that's what your mother told me. She must be
Yes,
sleeping. Even I didn't want to leave the books with the security because, you know, yeah, there's no reason. It is important, right? So
yes,
that's
ma'am.
why I called your mother. I knew she will be at college, but I just called her. Then she said she'll inform you.
Yes, ma'am.
Yeah. Okay. Now, what is the which block are they doing now in school, Swati?
Ma'am, they are doing multiplying algebraic expression, ma'am. Like LP4 identities have been completed, ma'am.
Sure. You've marked whichever is
Yes, ma'am. I
marked
have.
done in your. Now, just use your book and tell me which blocks are they still to do in your school. Just read out the numbers.
1 second, ma'am.
Yeah.
Ma'am, block 8
Block 8.
histograms.
Okay. Block 8.
Histograms, ma'am.
Okay. Block. No, just tell me the block numbers. 8, then
10, ma'am.
8, 10.
11,
Okay.
12,
Okay.
15,
Okay.
16,
Okay.
17,
All right.
18,
Okay.
20,
Hmm.
21,
Okay.
22,
Okay.
23, and 24, ma'am.
These are still to be done, no?
Yes, ma'am.
They have not done this so far. So
Yes.
now they're doing which one? Which block are they doing now?
Block 14, ma'am. Multiplying expression.
Okay. Fine. 13 they have done earlier, is it? Block 13.
Yes, ma'am. The previous block is adding and subtracting expression.
That's already done.
Yes, ma'am.
Okay, fine. So how many blocks are remaining to be done, is it?
Yes, ma'am.
Okay, fine. 6, 7, 8, 9, 10, 11, 12, 13. Okay, fine. Sorry, yes. We have already done algebraic expressions here. Are you finding it easy in school?
Yes, ma'am. It's easy, ma'am.
Okay.
Ma'am, but in laws of exponents, they are teaching something new, ma'am. Like you used to add and then find it, no, ma'am. But they are finding the like they're changing the power and then finding it.
We do change the power, no? You should not find the value. Are they finding the value and doing it?
No, ma'am. If it's in the negative power, if the base is same and the exponents are different, they used to reduce the power so that it becomes equal with the equal with the.
Yeah, that's what even I have done. Yes.
Ma'am, we have like if it's 25, we used to write it as 24 plus 1, ma'am, and that's different.
Anything can be done. You can write 25 minus 1 also.
Yes, ma'am.
Anything you can do. I don't remember which material that is.
And the story problem.
Yeah, no, that's what I don't know which one I've saved. Just a minute, wait. I don't. I think this one, huh?
Yes, ma'am.
Yeah, see? Yeah, tell me what?
Ma'am, here you have in order to make the base, in order to make the exponents equal, you have changed 11 as 8 plus 3, no, ma'am.
Correct, yeah.
Ma'am, instead of changing the exponents, they used to change the bases, ma'am. Like if it's 10 to the power 8, they you and another is 10 to the power 9, they used to put that decimal point before 10 so that the value decreases, ma'am.
Oh, okay. That's what it's the same. That's what we do here. Okay. So you tell me how they've done this one, this particular one. Tell me. You tell me
Ma'am,
using
there's
your.
a sum like this, ma'am. There is another sum, ma'am. Should I say that one?
Yeah, tell me.
Yes, ma'am.
No, you tell. No. You take a picture of the way your teachers worked it and send it to me. Now,
In the
now.
book itself, they have given me.
Textbook. Okay, textbook picture you send me.
Yes, ma'am. Ma'am, I have sent it.
Yeah. Hmm. Yeah, it amounts to the same thing. See, this one is 1.7 into 10 to the power minus 5. Okay. Minus 1 into 10 to the power minus 7.
Yes, ma'am.
Yeah, fine. So now we'll do the way it is in the book there. Okay. So now how can you write, they're bringing both to the same power. See, they're bringing both to the same power. So in other words, so they're writing 1.7 into 10 to the power minus 5, minus 1 into, how do you write, what is minus 7? Those steps are missing, that's all. How do you write minus 7 in terms of minus 5? It's the same thing. How do you write minus 7 in terms of minus 5?
I'm 0.01.
No. See, I'll tell you the difference is I have shown these steps extra. In the book, they've directly done this step, that's all. They've taken, see, finally have they taken 10 to the power something common, Swati?
Yes, ma'am.
Finally, what is common? 10 to the power minus 5 is common, right?
Yes, ma'am.
So these steps I have shown, there the steps are not shown, that's all. See, I'll do it now for you. Minus 7, I'm writing it as minus 5, minus 2, okay?
Yes, ma'am.
See, it's the same thing. I'm saying that I'm showing these two steps extra. There they've written this step straight away, taking this common straight away. Okay, see, I'll do it in the same way and show you that it's just like what is in your book. Is this step correct? Minus 5, minus 2, because minus 5, minus 2 is minus 7, correct?
Yes, ma'am.
Okay, so it is 1.7 into 10 to the power minus 5 minus 1 into, how do you write this? 10 to the power minus 5 into 10 to the power 2, right? Minus 2, right?
Yes, ma'am.
10 to the power minus 5 minus 2 is 10 to the power minus 5 into 10 to the power minus 2. Understood?
Yes, ma'am. Yes, ma'am. Understood.
Yeah. Now 1.7 into 10 to the power minus 5 minus, what is 1 into 10 to the power minus 2? That means 1 into 1 by 10 square, right?
Yes, ma'am.
1 by 100. 0.01. You must
Yes.
not disturb 10 to the power minus 5. You should write that as it is. Multiply these two.
Yes,
1
ma'am.
in,
Understood.
yeah, so it will be 0.01, 0.01. So this step they've written. It's just that I use these two steps for better understanding. That's all it is.
Yes, ma'am.
Yeah. Okay.
Yes, ma'am. Understood.
Okay.
Ma'am, and also for linear equation, they have a lesson plan for inequations, ma'am.
Yeah, inequation, that's only for only next seat for 8th standard. Otherwise, it's not in the I'll do it. I'm not saying I'll not do it. I'm just telling you. Inequalities is not a part of the board syllabus for 8th standard. It's an exceed. Exceed is a little higher version of the other books, no? So you have in Exceed. I'll do it. If you have, maybe if it's there for your final exam, I'll do it. Okay.
Yes, ma'am.
Yeah. All right. Yeah. I just want to give you an assignment. Please finish this. Yeah. Yeah. Please take a screenshot of this question. Finish this by the next class. Okay.
Yes, ma'am.
This one.
Yes, ma'am.
Yeah. Yeah, take a picture.
Took, mom. Took, mom.
Yeah, this one.
Took, mom.
Yeah. This one.
Yes, mom.
Yeah. Yeah, and this one. That's all.
Yes, mom.
1 minute. Yeah, this question.
Yes, mom. Can you show me the question 1 minute?
Yeah.
Took, mom.
I think I have the all the questions on one slide. I don't have. Yeah, this one.
Took, mom. Yes, mom. Taken.
Yeah.
Took, mom.
Yeah. Not this one, not this. Yeah, this one.
Took, mom. Yes, mom. Took.
Yeah, this question. I think this you already took earlier, right?
Yes, mom.
Okay, take
Yes,
it now
ma'am.
and check later. Yeah, that's all. What's the formula to find the number of diagonals in a polygon?
Ma'am, n into n minus 3 by Ma'am, n into n minus 3 by 2.
Very good, very good. Both of you told me the correct answer. Very good. All right, girls. So that's it for today's session. Thank you so much. You may leave the call, but just a minute, I'll tell you about the physical. Please wait, I'll just tell you about the physical classes.